there, the electron goes in to make the double bonds single between the, because these are carbons in here. So now you got one double bond down here, where before you had two double bonds with no hydrogens out there. So this shows the reduced hydrogen. And what we show with the comic here is, Centipede says, I got reduced, but added H2. That's two electron sizes I lost from my waist. N added to my bust and hips. So N up here, N down there got bigger. Her hips got bigger, her bust got bigger. Hips got tighter, more of the bee, what do they call it, the bumblebee kind of thing. Okay, so let's back that up a little. Let's see what else we have for your enjoyment here. Now the fun thing of this too, when you really want to get into the intricate chemistry, is things like the riboflavin, okay, they will become part of bigger molecules. When you got the cartoon character here, I think it's so cool because here's vitamin B2 with the ribo's the 5 carbons. Okay, now it bonds to a phosphate, phosphoryl, another phosphoryl, so-called a diphosphate. They call it a diphosphate, but they're diphosphoryls to be correct. And then what it bonds to is ruby ribose. Now ruby, red, rubies are red, right, is an adenine. That's from RNA, because it's got the OH here. This is the OH that if DNA, the OH is missing. So this is an RNA. Now ruby, here's another ribose sugar in a lactone, I guess they call it, because it's a circular. So 5 members here, 1 oxygen, 4 carbons, and then a 5th carbon is out here making the elbow. And what she's holding is adenine. So here's the base adenine. Remember your DNA, RNA stuff? Well, here's adenine, ribose, call her ruby ribose. Ruby always holds adenine, so we give an adenine a red color. This is part of a big molecule here. You got B2, 2 phosphates, ruby, and adenine. So by the cartoon characters, you can see what the portions are. When I was seeing these in the books for years, I couldn't keep track of what was what. So I guess we'll go up here and show you what the DNA representations go like. This, by the way, was called the FM flavin mononucleotide. Oh boy, I get my names mixed up. This is another part up here where adenine, let's move the whole table over here. Adenine here, right? Adenine is holding the sulfur, and does this look familiar? This is part of methionine. So this is called S, because of the sulfur, adenosyl methionine. So you got your whole little groups here with your ruby ribose. Whenever you hear ruby, you'll think she's got the adenine with the ribose, OH, because it's RNA. Another OH, because it's not bound to anything like it usually is here. These are called your 3,5 carbons. Those are the ones that get bonded, but here they're just OHs because they're not bonded. And your S bonding methionine. S is part of the methionine. So this, if it looks familiar, is the backbone part of an amino acid. That's the part that's usually up and the sulfur hanging down. That's methionine. So this is part of our nutrition, a new way to learn how your nutrition works. Since we're talking nutrition, we'll skip over here. With this cartoon character stuff here, we can compare sterol rings. This is what your testosterone. Now, I play games with this. Testosterone. One means there's one one, a lone ketone. That's out here. Now compare these. This is a a regular sterol backbone, they call it. There's an A, B, C, and then a little D ring. Well, this is estradiol. So here you can compare the difference between the male sex hormones and the female sex hormones. This is a ketone. This is an alcohol on a estradiol. Now, di means 2, so where's the other OH? Up there on the D ring. Compare it here. You can see this is aromatic. This only has a single double bond. This has a methyl here, no methyl on that. This has a methyl up there, it's got the methyl up there, so that's the same. So you can compare the rings. A lot of similarities between estradiol and testosterone, huh? Now, talking about nutrition, this was the one I was saying before. Let's see if we can zoom in on this a little better. So we'll just concentrate on these two. Too much, too little, too late. Oh, get this out of the way here. See, that jumped up on me too. Only as soon as you start the film rolling there, and everything goes to heck. Right there. Vitamin D. Vitamin D has the same sterol, see the ABCD rings on it? OH, like estradiol. It's got a 5, these are isoprenes. When there's 5 carbons, you'll see there's a predominant theme. Even turpentine gets its name from that. Terpenes, these are made a lot in trees. You'll see the 5 carbon thing going through there in plants and stuff. Okay, vitamin D, see the A, B is aromatic, C, D. Now what happens when the UV activates this is what you need to happen. You need ultraviolet, high energy to break that bond open. It's ultraviolet B, this is the higher ultraviolet energy one, not the low energy. So sunscreens there's a lot of debate on what's really good with a sunscreen. But see the way the aromatic 3 double bonds in that ring now opens up, still got double bond to a carbon, 2 double bonds there, but the ring is open. The B ring opens up. See, here's the benzene, the aromatic, the 3 bonds inside the ring. See the way it gives it a little face? Here he's sad because he says, I need some sunshine. He wants to go to the beach. He's like you kids in school. You're stuck in the classroom right now. Okay, let's go. Let's stay on this side of the table here. So here's another concept, topic, sugars. Now, sugar is a generic term for, God, there's just so many different types of sugars and carbohydrates and other names for them. But we're going to compare different ways of drawing sugars. This is what galactose and glucose are 6-membered rings with the oxygen, so they get other names like lactone whenever the oxygen, because you can see it drawn straight, but as soon as it's in water or blood or biological system, it forms a ring. So it's got 6 carbons, but 1 will always be on the outside, and the oxygen from an OH is inside the ring. OHs on these, well, they're up and downs when you see this in 3-dimensional structure here. So we made a little trampoline out of it. So when you see this drawn, I had to fit it sideways, fit it on the picture. This is down like a leg, that's down like a leg, this one's up. That's down like a leg, so it's like it's standing on those feet. And that way you can tell if these OHs are up or down. Galactose, see a gal waving, see she's waving. Well, gals, women, mamas make milk. So mama's milk, galactose, lactose intolerant, lactose, that's a milk sugar. Okay, so now again, the power of the drawing. Look at the fructose cheerleader. She's got an OH going down like a leg, and this leg she's kicking up in the air. These OHs are her hands, like rah rah, zis boom ba, let's hear it. Fructose is 5-membered ring. with the O in there, not a 6-member. So this gives 1 carbon on the arm and another carbon coming up here for an arm to an OH. That O will go on to be a different bond there. And then this is what they call the boat and chair configuration of 6-membered rings. So here's a glucose, call it the glucose rug or a towel. See the way it just lays there? So this is a good 3-dimensional structure to show where these carbons are going. There's that 5 carbon that's not in the ring, so that goes up and holds it. The H's aren't drawn on these. This is for chemists that really know their stuff, so we don't draw the H's in there because it's given that you pretty much know what they are. We're going to come over here. I can see this is one where it got all messed up. This was the other one we were talking about, flavins from the riboflavin. Does a glucose breakdown. See, nothing's working here. This is really messing up. This is funny. This was working so good until I come to down here. So get this out of there. Actually, that was part of it. See, this is weird. Anyway, zoom in a little bit here. This ring in here, nitrogen, this will take, instead of 2 protons, 2 electrons, it'll take 1 proton, 2 electrons, and then another proton goes in a solution. So these are the only 2. The riboflavin, remember I showed you the riboflavin? When you're breaking down sugars, and this happens in your mitochondrion, this is what's so unique about it. So you got this one taking electrons and a proton, and you got the other one. This is from your B3. So it does all these different structures. That's why you hear nicotinamide, nicotine, amide, get it? He's smoking a ribo ADP. This is part, like up here with ruby, it's part of a longer molecule, a ribose and an ADP. Well, that's kind of what was up here, right? For the same structure with ribose holding on to ruby there. Down here you're going to have the NAD with a ribose, ADP, that's an adenine diphosphate, which is almost exactly what the flavin was up there. Diphosphates, 2 phosphorus, there's the adenine, and instead of being bound to the nicotinamide single ring structure, it's bound to your B2. So see, by playing with the cartoons on this, you can compare things a lot easier, I think. ADP with ruby, and see again, it's got the adenine up top there. This is one I get confused because it's a misnomer. They call it like flavin mononucleotide, but it's not a FD. They call it dinucleotide, but there's only one nucleotide, the A. So I'm confusing myself. So if you're confused, you're right on track. So again, here is the other one from nicotinamide, NAD plus. Plus is on the nitrogen because it's doing 4 bonds here. It's got a double bound to a carbon, single bound, that's 3, and then the 4th goes to the ribo, which is a 5-membered sugar ring like ruby, and ruby's holding on to an ADP, adenosine diphosphate. So somewhere in there is smoking a NAD cigar, smoking an ADP ribo cigar. I think the way it should be is it going to give me an arrow? I think the way it should be is that should be down there, and that should be up. That should be up there. That should be down. That's the way it should be. But not concerned because this is not going to be saved this way. So up here, let's show water. Everybody